Okay, so our next lesson is I can find key features of graphs of rational functions. So anytime that we've talked about key features in the past, we usually think of domain, range, increasing, decreasing. We're going to add like a few more aspects of that when we get to rational functions. And then just keep in mind, rational just always remains our favorite fractions. Yay! Okay, so rational functions, a function of the form p of x equals, it's usually going to look like this. It's a little weird why they do this, but it's just a fraction. That's all it is. So it's got a numerator, q of x. It's got a denominator, r of x. So you're just putting a bunch of different expressions together. So here's the three things that we're going to focus on when we do key features of rational graphs. We're going to talk about holes, we're going to talk about vertical asymptotes, and we're going to talk about horizontal asymptotes. So everything that we've done up until now, domain, range, increasing, decreasing, constant, positive, negative, all of that stuff still applies, but we're going to add these three things that are going to be new to this unit. Okay. So what I've done is I've tried to use Desmos, so some of you have access to it, some of you do not, so I just put pictures on here in case you don't. So first thing we're going to talk about is a hole. A hole is a break in the graph. You cannot see it on a graph, but there will be an error at that x, y coordinate point in the table. So this is kind of a bad example of a rational, just so you know. It looks like a rational, it actually becomes a linear. So if you look at the graph, it's just a straight line. And notice that we don't have any breaks in that line. So what I've done is I've shown you the table over here. And there actually is a hole at -3. So here is -3 on the graph. There's no break right there. But when you look in the table, you get that undefined, or if you were looking on a TI-84 or TI-83 graphing calculator, you would see the word error. So that just means that there's a point of discontinuity right there. So there's a hole right there, and we're going to talk about how you know if it's a hole or if it's a vertical asymptote or something like that. Okay, so to find a hole, there's three things we're going to do. One, we're going to factor the numerator and denominator completely, as we always have this whole unit. Two, a hole will be where there is a common factor on top and bottom of the fraction. And then three, we're going to set the common factor equal to 0 and solve. So first thing we're going to do is we're going to factor the numerator and denominator. So if I look at the numerator, it has a GCF of 2. And then I'm going to take out that 2, so I'm going to divide each of those terms by 2. So 2x divided by 2 is x, and then 6 divided by 2 is 3. On the bottom, there's not a GCF I can bring out, so it just stays x plus 3. So we have step 1 taken care of. We have factored completely. And then step 2 says a hole will be where there is a common factor on top and bottom. So I'm looking for something that's exactly the same on top and bottom. So if you'll notice, there is an x plus 3 on top and an x plus 3 on bottom. That's my common factor. So x plus 3 is my common factor. And then step 3 says set the common factor equal to 0 and solve it. So we set it equal to 0. The way we get rid of a plus 3 is to subtract. So x equals -3. So what this means is there is a hole on this function at x equals -3. So I'm going to flip back to that last page we just looked at. And that was if you'll notice, that's the exact example we just worked out. Notice that when we did this graph, there was not a break in the graph at -3, but when we looked at the table, we did see an error message, or we got undefined at -3 because there was a hole there. So that's what we're trying to do when we're finding a hole. Okay. Alright, so the next one is vertical asymptote. So it's a little bit different than a hole because it's a vertical line, or it could be several lines, and if you have forgotten what vertical means, that means up and down, that correspond with the zeros of the denominator. So it's a little weird, but here's an example of a rational function. And there is actually a straight up and down line. It's invisible, you can't really see it. But if you think about where I just drew that line, like an invisible line that graph is never going to touch, that's going to be that red line right there. That is your vertical asymptote. And I'm running out of room. Okay, so let's look at an example of that. So to find a vertical asymptote, 1, factor out the numerator and denominator completely, just like we did. 2, cross out common factors on top and bottom. We're crossing those out because those are the holes. So we don't want to repeat anything. So we're going to get rid of the holes. And then 3, we're going to set remaining factors of the denominator only. So notice it says denominator, not numerator, equal to 0 and solve. Okay. So first thing, I want to factor the numerator and denominator completely. So the numerator, I can take out a 2 GCF, and I'm left with x plus 3. The denominator, I have to factor that quadratic. It's the shortcut method. I'm just looking for two numbers that multiply to give me -3, but add to give me 2. So x plus 3 and -1. So that's step 1, factor numerator and denominator completely. Step 2, cross out common factors on top and bottom. So I'm going to cross those out because there's a hole at x equals -3. I'm not finding a hole, I'm finding a vertical asymptote. So once I have crossed out anything it has in common, I'm going to set the remaining factors of the denominator. So that's the only one I have left, x minus 1. I'm going to set that equal to 0 and solve. If there were multiple ones, then you would set all of them equal to 0 and solve. But in this case, we just have x minus 1. So if I set it equal to 0, to get rid of -1, I add. So this means I have a vertical asymptote at x equals 1. So if I go back to that previous page, notice there was a line straight up and down at x equals -1, and that's my vertical asymptote. Okay, so then the last one's a little bit different. This is our horizontal asymptote. So a horizontal line, which goes from left to right, that the graph can never touch. So it'd be like right here. So here's my function I graphed, and then I'm looking for a left to right line that the graph can never touch. So this is how you do that, and I know you're really impressed with this chart. I know, I did it myself. Thank you. So to find a horizontal asymptote, number 1, you're going to find the degree of the numerator. So if you have forgot what that word degree means, that's your highest exponent on top. Alright, and then number 2, I'm going to find the degree of the denominator. That's your highest exponent on bottom. And then I'm going to use this chart to look at this. So if you'll notice the first one, if the degree of the top is greater than the degree of the bottom, then you have no horizontal asymptote. So if you look at the example, the degree of the top is 2, the degree of the bottom is 1, the degree of the top is greater than the bottom, so that's why you get that no horizontal asymptote. Alright, the next case is if the degree of the top is less than the degree of the bottom, you'll have a horizontal asymptote at y equals 0, and in case you have forgotten, that's just your x-axis. So when you look at the example, the degree of the top is 1, the degree of the bottom is 2, 1 is less than 2, that's why you have a horizontal asymptote at y equals 0. And then the last case, let me get a different color, if the degree of the top is equal to the degree of the bottom, then what you do is it's going to look like a fraction. It's going to be the leading coefficient. So remember, coefficient is the number in front of the letter. So 2 divided by the leading coefficient of the bottom, 3. So I would actually have horizontal asymptote at y equals 2/3 in that case. And that's the only 3 things that can happen. So either you're going to have no horizontal asymptote, you're going to have a horizontal asymptote at y equals 0, or you're going to have a horizontal asymptote as y equals a number divided by a number. Okay. So we're going to do this example together. We're going to find the hole or holes, the vertical asymptotes, and the horizontal asymptotes. And sometimes they don't have any of these. You just have to look at it. So what I've done is I've included a picture of this. So here's your graph right here. So I graphed this in Desmos. That's what it looks like. And then I also over here pulled up your table, so you can see already that you have 2 error messages, 2 undefined places at those 2 points. You just don't necessarily know which one's the hole, which one's the vertical asymptote until you actually do this. Okay. Alright, so I'm just going to move these down for right now. Okay, I just needed more room, but now we can see. So the first thing we're going to look for is a hole. So we're going to factor the top and bottom completely. So here's the top, nothing to do there. The bottom I can take out an x, and I'm left with x minus 6. So my hole is anything they have in common on top and bottom. Notice that they both have that x minus 6, so that's going to be my hole. I'm going to set that equal to 0. So I have a hole at x equals 6. So right here, that was my hole. Alright, so once I have that, I'm done. So now I'm looking for my vertical asymptote. And so I'm going to look at what's left on my denominator after I get rid of the hole. The only thing that's left is this x right here. So I'm going to set that equal to 0. So that means I have a vertical asymptote at 0. So that right there was my vertical asymptote. Okay, then the last thing I want to do is I want to look for, I'm going to use that chart from that last one. So notice that the degree of the top is 1, that's my highest exponent. The degree of the bottom is 2. So I'm going to flip back to that chart. When the degree of the top is less than the degree of the bottom, you have a horizontal asymptote at y equals 0. So horizontal asymptote at y equals 0. So those are your 3 things that you were looking for. Alright, I'm going to let you try this one. So hit the pause in 1, 2, 3. First thing you want to do is factor this completely. Okay, I have factored it completely, so now I'm trying to find a hole. The hole is going to be wherever they have something in common. Okay, so they had a common factor of x minus 1. I've circled it in red. I set that equal to 0. It equals 1. Now I'm looking for a vertical asymptote. So remember, a vertical asymptote is wherever you have another factor other than the hole, just on the bottom. So I circled it in blue. It's that x minus 3. I set it equal to 0. It equals 3. And now I need to find the horizontal asymptote using the chart. So if you'll notice, the degree of the top is 2. The degree of the bottom is 2. Remember that there is an understood 1 in front of each of these. I can go back to the chart if I need to. The chart says if the degree of the top is equal to the degree of the bottom, then I look at the leading coefficients. So the leading coefficient of the top is 1. The leading coefficient of the bottom is 1. And 1 divided by 1 is 1. So you have a horizontal asymptote at y equals 1 divided by 1, which is 1. So hopefully that made sense. And if not, you can email me questions, hit me up on the Remind app, do whatever you need to do. Okay, bye.